Okay, good morning, children. Welcome to the new session 2021. This is the first class in maths. It would have been a nice thing if we had been in the classroom. Still, the pandemic is not over, coming to an end, I'm sure, with the vaccination taking place and vaccine being made in India. So, we are going to start this year with online class only. So, we are going to start with the first chapter in your book. So I'm still using the same book, ICC Numbers West, Class 7, Course in Mathematics, S.K. Gupta, Anupati Gunga. Okay, this book. So all of you should try to get the book. It will be easier. If not, I'll be teaching. You can just follow me. Okay. So the system in place, or you can get the book from the school also. Just get in touch with the administration, to the professor and all, or to Rasa. They'll let you know. So we're going to start with integers and what are integers? It's an introduction for you, class 6, so you might not have done this. So if you go through the book or what the book says, it says whenever you add two whole numbers, it says you get a whole set of whole numbers, it is closed. Basically, when you add two positive numbers, you get another positive number, a whole number. Okay. Now, but whenever you try the same thing in subtraction, it does not become closed. That means you don't get a whole number. You get a negative number. For example, let's take two whole numbers, 4 and 9. When you subtract 4 from 9, you get the answer as 5. 5 is a whole number, right? But at the same time, if you subtract 9 from 4, the answer is -5, which is not a whole number. This is a whole number, okay? This is not a whole number. So that's where the problem arises, right? So in maths, you cannot only deal with whole numbers because maths is vast, it is wide. There's a concept of infinity, numbers are infinite. Even if you circle the globe 1 million times, numbers will never end. It will keep going on and on and on and on. Okay, so to limit the possibility of playing around with numbers, it's not a good thing. It was not a feasible thing to do. So, keeping this in mind, the concept of integers had to be brought about. Okay, now, before I go into integers, a little bit of recap, first class. What are whole numbers? What are natural numbers? What are integers? Okay, so whole numbers are numbers that you start from whole numbers. Symbol is capital W. Okay, it's numbers that you start from 0, etc. Okay, it keeps going. Right? Now, natural numbers. Natural numbers. Capital N. It's not 0, 1, 2, 3, 4. Continues. Right? So this is what it's all about. Now, if you see 0, 1, 2, 3, 1, 2, 3, they are numbers beyond 0 also. If you go towards the left side of the 0, this is towards the right side. But if you go towards the left side, there are numbers like -1, -2, -3. Okay, so this area is being left out. This is what I was trying to tell you. When we were dealing with whole numbers only, addition was possible, it was close, we were getting another whole number. But in subtraction, we were getting minus numbers, yes. So what would we do? Deal with, how do we go about it? So that's how the concept of integers came about. Okay. So the book says, thus this operation cannot be performed even if you have the set of whole numbers to work with, that -5 that I was talking about. So we extend the set of whole numbers to include negative natural numbers. This new set comprises whole numbers and negative numbers, and the negative of natural numbers is called a set of integers. Okay. So what is integers? Integers is nothing but you either write it as I, capital I or capital Z, and it includes the negative numbers. Let's do from -3, -2, 1, 0, 1. Okay, it continues this side, it continues this side also. So this was integers. Okay, everything was included in. Basically, everything was included in integers. Minus numbers, 0, and the positive numbers thereafter. Understood? So, symbol for integers is I or Z. Okay, and these are, as I told you, negative numbers, 0, and when we have a set of negative numbers, then we have the 0, then we have the set of positive numbers. That's what integers were all about. Okay, so all these numbers towards the right, they are called positive integers. Towards the right of the 0, okay, this is the right side of the 0, they are called positive integers. All the numbers towards the left side of the 0, they are called negative integers. Okay, 0 is neither negative nor positive, and 0 was a number that was given by, that came from India. Okay, I think it made so much of a difference when 0 was given. Before 0 was there, we just had the natural numbers. Okay, that would limit again computing in maths. That would limit the way you do maths. But once 0 was given, the whole world was opened up. In fact, 0 makes a lot of difference when it is after a number. Even if it's before a number, it may not make a difference, it may not have much of a value, but still in certain places we have to use it. But if it's placed after a number, it makes so much of a difference. It increases the value of a number. Like we have the number 1, you place 0 in front of 1, this is just 1. If you place 0 after 1, it becomes 10, you place 1 or 0, it becomes 100. You know, it keeps increasing the value of numbers. Okay. So, both the positive and negative integers are called directed numbers. Why directed numbers? Because they have a direction. As I told you, 0 is the midpoint. Towards the right of the 0 is positive numbers. Towards the left of the 0 is negative numbers. So we have direction. We have left and we have right. That's why they are called directed numbers. Since they indicate direction. And another name given to them is called sign numbers. Why? Because these are all positive and these are all negative. We do not write, see, whenever we write a name, number, we do not write the sign. Okay, if you don't write the sign, it is understood that it is positive. Okay, but if it's negative, then we write a negative sign. So that's why they are also called sign numbers. Okay. So note is given in the book. Okay, since some of you or most of you may not be having a book, just follow what I am saying. I am just reading from the book because you'll have to use the book also. So it says, for every positive natural number, let's say any natural number, for every positive natural number, there exists an opposite number called the negative of the number represented by. Okay, so for example, 2, I've taken 2, for plus 2 on the number line, it will always have an opposite of it. So plus 2 will have minus 2. Plus 1 will have minus 1, or plus 3 will have minus 3, so on and so forth. That's what they're trying to tell you. Okay, so for every positive, like they say, no, a person has two sides. They have a good side, and then they have a bad side. They say on you have got two shoulders, right? On one side the devil is there, on one side angel is there, God is there. Similarly, for every positive number there is a negative number, or for every negative number there is a similar positive number. Okay. The sum of any integer and its negative is always 0. That's very true. Let's say I have to compute this. Plus 2 minus 2. What would happen? Plus into minus is minus. Action will be minus between them. So 2 minus 2 will be 0. Understood? So it kind of cancels itself. Understood? Okay. So whenever a positive number encounters the negative number of the the same, the duplicate of it, and if there's a computation that has to take place or you have to compute between them, sign rules will be applicable, plus into minus. See, if you encounter a number like this and they say give the final answer, so what would you do? There are rules in maths. So what would you do? Plus and minus, you have to compute the sign rules first. So plus into minus is minus, action will be minus, so 2 minus 2, 0. Okay, that's what this rule is trying to tell you. The third one, for the sake of simplicity, we omit the plus sign and write a positive number as a number itself. Like when I wrote this numbers also, okay, I did not write plus in front of because it's understood. If you don't write any sign, that means it's positive. We only write the sign whenever number has to be shown as negative. Okay, so in this case also, even if I remove this plus sign, it is understood. That's why 2 minus 2 will be 0. Okay. Now, representing integers on a number line. What is a number line? Okay, we just take a line. Draw a line. There will be a midpoint. Midpoint is always signified by a 0. Then towards the right side of 0. Okay, we have the positive numbers. I'm not going to write the sign for your convenience. I might just do it. But please understand that if you don't write any sign, it is understood that it is positive, as I've already told you. Okay, so on and so forth. And towards the left hand side, we have negative numbers. So on and so forth. Okay, so this is the midpoint or the border between the positive numbers and the negative numbers. Okay, so positive numbers will always move towards the right side. That's why they are called directed. And this is the left side. Always keep arrows also is indicating what side it moves. Okay. Now we come to the term called predecessors and successor. What does a predecessor mean? Pre means before. If you have to break down one predecessor, something that comes before you. So book says one less than a given number, one less than a given integer, not number, one less than a given integer is called its predecessor. Thus, on the number line, each integer is the predecessor of the integer just on the right of it. Each integer is a predecessor of the integers just on the right of it. So 0 is the predecessor of 1. 0 is the predecessor of 1. Minus 1 is the predecessor of 0. Minus 2 is the predecessor of minus 1. Minus 3 is the predecessor of minus 2. Similarly, 2 is the predecessor of 3, 3. Understood? The concept is simple. You just have to remember that an integer is the predecessor of the integer just on the right of it. So, what is on the right of it? Just take any number from the number line. Let's take 3. What is on the right of it? 4. Okay, that is the predecessor. What is successor? That's huge. What is the successor? Again, let's go by the book. What the book says. Successor is one more than a given integer is called a successor. Thus, on the number line, each integer is the successor of the integer just on the left of it. So, minus 2 is the successor of minus 3. So, let's take one number. Let's stick to 2. Okay, so 2 is the predecessor of 3. 2 is the successor of 1. Okay, so it's all about right and left. That's all you have to remember. Don't get confused, don't think too much, don't go by words are there in the book. It's just, if the words are long, if you think it's complicated, it's just trying to explain it to you. Books is trying to explain it to you, the teacher is trying to explain it to you. Just remember, towards the right is predecessor, towards the left is successor. Okay. So we come to the concept term called comparison of integers. For any two integers represented on the number line, the one indicated on the right is greater. The one indicated on the right is greater. Okay, so again we'll take 2. What is towards the right of 2? 3. So 3 is greater than 2. Again, let's take 3. What is towards the right of 3? 4. So 4 is greater. So similarly, let's go towards the negative side. We will take minus 2 and minus 1. Okay, or 0 and minus 1. 0 is towards the right of minus 1. It is greater. Minus 1 is towards the right of minus 2. Greater. Minus 2 is towards the right of minus 3. Please, children, if we were in a normal class, my favorite question is, I see this number line, this concept of negative numbers, positive numbers, everybody says, yeah, we understand, but when it comes to valuation, okay, value as to which is greater and all, I put up questions like, we talk about temperatures, right? We talk about low temperatures and very, like Antarctic, it goes up to minus 70, minus 90 degrees also sometimes. So let's say 1 degree Celsius and minus 70 degrees Celsius. Okay, and I asked children, which is greater? The common answer that I get, the usual answer that I get, I'm going to pause right now. So you guys also going to go through this video. When I'm putting up this question, you tell me which one is greater between minus 1 degree Celsius and minus 70 degrees Celsius. Most of you will choose this because 70 is greater than 1. So 70 has to be greater. Okay, but no. 1 is greater than minus 70. Understood? So what this shows is this temperature is, it's so cold that it is 70 points below 1. Understood? Minus 1, minus 70. It shows that how cold it is. See, this is the freezing point of water, 0 degrees Celsius. From here, water starts getting frozen more and more, cold gets cold more and more and more. Okay, so please don't get confused. Minus 1 or 0, I think there are some points in this also when you come to that. There are notes that I think 0 will be always greater than all the negative integers. 0 will be always smaller than all the positive integers. So, thank you so much, children. We'll continue with this later. Just go through. I'm not giving any sound anything right now. Just an introduction. Just go through what I've said, especially the predecessor and the successor, and please understand the concept of the negative numbers also. Thank you.